Yesterday we completed about the IPsec. We understood like under the IPsec we have I, we have ESP, we have AH. We understood we have two versions under the I, and they has two phases as well. So we understood about the IKEV1, we have the phase 1 and phase 2, and we understood main mode and aggressive mode and the quick mode as a phase 2. So I told you we'll discuss about the message exchanges. So let's discuss about the message exchange over here. About the message exchange. You can see your Internet Key Exchange version 1. This is your IKEV1 phase 1 main mode message number 1. What do we see here? In main mode, message exchange means the first message exchange. What happens? Transform payload contains the transform number, transform ID, and the IKE essay. Okay. Attributes. From here, the important line you can see. The attributes like authentication, pre-shared key, or the digital certificates, hashing algorithms like MD5, SHA-1, and the encryption like DES, 3DES, or AES, and tunnel lifetime, and the Diffie-Hellman group. So it's basically when you combine it in a form of Haggle, you'll see all those things are being negotiated in the first message exchange. Initiator and responder must calculate the value called as cookie. Cookie value is used to protect IPsec peers against the DOS and the replay attacks. RFC suggests a method of creating the cookie by performing a fast hash. That's your MD5 over the IPsec source and destination addresses. The UDP source and destination port and locally generated secret random value. The field initiator SPI marked in below capture is the cookie value generated by initiator. A responder cookie value is kept as empty because this is the very first message exchange. Now, if you see, we have an initiator and we have the responder. Now, if you check here, this is an initiator first message exchange in which you can see the information, whatever you see here. This is actually the Haggle information. It is sharing its like authentication, encryption, hash, lifetime, group, all those parameters. But are you able to read it? No. It's in the form of cookies. We call it cookies. Now, initiator SPI parameters are this. Now, when you get the response in the second message exchange, you will see the agree packet. We also call it as the agree packet that you'll get the reply from the responder. And these fields should be filled with the values. Now let's see the second message exchange. IKEV one main mode second message is the response from responder to the packet sent from the initiator. Purpose of message 2 is to inform initiator the ASA attributes agreed upon. So I agreed your proposal and I'm saying, okay, I'll follow the same encryption, same hash, same type of all the parameters, whatever you proposed me. Okay. Most of the fields are the same as in the packets and in the initiator. Only one proposal payload and the transform payload is there in the message 2, which is the agreed proposal and the transform payload. Also note both the cookies values are filled. if you see here, can you see both the cookies value, like initiator and the responders values, are filled? So basically, what do you see? These informations will be under the ISACAM. Can you see ISACAM? Initiator Security Association and the Key Management Protocol. This is responsible for your key exchange. This is the protocol used in the phase 1 for the key negotiation. And it works on the UDP port number 500 as a source and the destination. So you can see the UDP protocol with the source and the destination port number as a 500 used. And you can see below that we have the Security Association Key Management Protocol with the initiator and the responder parameters. Correct? So entire 6 message exchanges you will see under the ISACAM itself. Now, the third message exchange of the direction is from the initiator to the responder. This message contains a Diffie-Hellman key exchange payload and the nonce payload from initiator. So if you see the packet over here, what do you see in the packet? Like you have the key exchange with the nonce value. You can see this is the nonce data and this is the key exchange data. So both the values from the initiator to the responder and responder to the initiator, these 4 message exchanges will be done. Now we'll go to the 5th message exchange. Now if you see, 5th message contains identification payload and hash payload from initiator. Identification payload and hash payload are used for identification and authentication. Identification payload and hash payloads are sent encrypted in IKEv1 phase 1 main mode. So basically identification means like authentication and encryption gets started from which message exchange? That's your 5th and 6th message exchange. So the same identification and the encrypted packet will be coming from the 6th message exchange from the responder to the initiator. The 6th message exchange contains the identification payload and the hash payload. Identification payload and hash payload are used for identification and identification from the responder. Okay, so basically it's like both the ways you are identifying, and you can see like identification and the encrypted data. So this is how both the ways 5th and 6th message gets exchanged. And once the authentication happens successfully, then what happens? Then once the authentication happens, then the phase 1 will get established. And once the phase 1 gets established, then only the phase 2 like quick mode will get established. And before it establishes the quick mode, it will re-verify. 3 message exchanges will be there. See here, in the quick mode, what will happen? In the quick mode, it will initiator to the responder and responder to the initiator. It will re-verify the SPI parameters. The SPI parameters which was exchanged in the first and the second message exchange will be re-verified, and once it is re-verified, then the real data will be exchanged. So this is how the quick mode comes up, and the quick mode will be checked every after 1 hour, because the tunnel lifetime for the phase 2 is for 1 hour. So every after 1 hour, what will happen? The phase 2 tunnel will be re-verified. Your phase 1 tunnel will be verified or re-established after the 24 hours, because the lifetime for the phase 1 is for 24 hours. So every after 24 hours, it will renegotiate all the phase one parameters. Okay. Yeah, these are the basic things what I'm discussing. Yesterday, you guys were not able to answer the questions, so I had to start from scratch. Okay. Now, talking about the aggressive mode. Why aggressive mode and why, why main mode, why not aggressive mode? In aggressive mode, we'll have the 3 message exchanges, including with the quick mode, it will be 6 message exchanges. Main mode and quick mode equals to total 9 message exchanges. That's your maximum. And the minimum would be aggressive and main mode. That's sorry, aggressive and quick mode. That's your 6 message exchanges. So basically, in IKEV1 phase 1, when aggressive mode uses only 3 message exchanges to establish IKE-SA. The first 2 message exchanges in the aggressive mode exchange include almost everything required for the IKE-SA. So basically, the initial 2 message exchanges from the initiator to responder and responder to the initiator will almost contain all the parameters. Okay, IKEV1 phase 1 aggressive mode is quicker than the main mode, but the endpoint identities are exchanged in the clear text. So basically, what did you understand? The endpoint identities, whatever the identification will be done between the two devices, like fifth and sixth message exchange. Here it will not be in the encrypted format, it will be in the clear text. If the identification itself happens in the clear text, it's not secure. Okay. When comparing main mode and the aggressive mode, the main mode is considered more secure than the aggressive mode because the identification payload is encrypted in main mode. So I hope you guys have the solid reason to give a reason in the interviews why not aggressive mode and why the main mode, right? If I see the main mode, if I see the aggressive mode first message exchange, IKEV1 phase 1 aggressive mode, all necessary information required to generate Diffie-Hellman shared secret key is exchanged in the first 2 message exchanges between the pair. So basically your proposal and the Diffie-Hellman key itself is shared in the first message exchange and the second message exchange. The first message sent from the initiator includes SA payload, SA proposal payload, transform payload similar to main mode. This difference, the main difference in the aggressive mode is that the first message includes the Diffie-Hellman key, payload, nonce payload. So basically, the first message exchange and the third message exchange, whatever was contained in the main mode, will be included here in the first message exchange itself. So basically, the proposal and the key generated by the Diffie-Hellman along with the nonce value will be in the first message exchange. Okay. Identification payload is also added in the first message. So basically, first, third, and the fifth message exchange included in the first message itself. Note that note that the identification is sent in the clear text, not encrypted. Now, when I talk about, you can see here like SPI parameters. You can see here key exchange, like key data, and you can see the nonce value. You can see the nonce data. Two things like first message exchange of the main mode, third message exchange of the main mode, and okay, and you can see here identification data, right? So basically these things are shared over here. Now In the message to now the responder can generate the Diffie-Hellman shared secret. The responder generates Diffie-Hellman shared secret. Responder generates the hash also from the authentication, also for authentication purpose, similar to message to in IKEv1 main mode. Message to in IKEv1 phase 1 aggressive mode also contains the agreed proposal and the transform pair from the responder. It also contains the key exchange payload, nonce payload, identity payload, authentication hash from the responder. So basically, again, again the same parameters like 2, you can say 2, 4, and 6 message exchange, right? Once they are exchanging, then the third message exchange. Now the initiator can generate the Diffie-Hellman shared secret. The initiator generates the Diffie-Hellman shared secret key. Initiator generates the hash also, algorithm purpose. The hash payload is sent as a encrypted. Phase 1 can be negotiated using the main mode, aggressive mode, main mode, or the aggressive mode. See, basically in a here you see, like in the identification along with the first and the second message exchange was exchanged between the two sides. And you can see the same value over here. Aggressive mode. Now the initiator can generate the Diffie-Hellman shared secret. The initiator generates a Diffie-Hellman shared secret. Initiator generates the hash also for the authentication purpose. The hash payload is sent as a encrypted. So basically, the third message exchange will happen from the initiator, okay, and generates a Diffie-Hellman shared secret key and does the encryption at the last message exchange, okay. So this is how the communication happens only in the three message exchange, okay, and it works. So this was your main mode and the aggressive mode. Only the why don't we use aggressive mode is basically the identification what was shared in the second and the first and the second message exchange was not in the encrypted format. That was in the clear text. Once the identification happens, after that, receiving the shared secret key, I mean like Diffie-Hellman key generated by both the sides with each other, then only the encryption gets started. And that happens only for the data. Okay. So basically your identification means authentication happens in the first and the second message exchange itself. Then the real data is encrypted. So basically that identification what was happened in the first and the second message exchange was supposed to be encrypted, was not supposed to be in the clear text. Okay. Now, so these were the details of your site, your IPsec VPN guys. Sorry, IPsec protocol. I hope you guys understood how your IKEv1 with the phase 1 and the phase 2 negotiation they will work and the packet will be exchanged. Let me make very clear. We are going to use main mode and the quick mode for the traffic encryption between the IKEv1, wherein when you work with the IKEv1, phase 1 will be known as a ISACAM and the phase 2 will be known as a IPsec. In phase 1, the protocol is used as a UDP port number 500, that's your ISACAM, and in phase 2, we use a protocol ESP or AH. So for security reason, we are using ESP, not the AH. Am I clear? So this is done. Now let's do a lab. Any questions so far? Now I want you guys to take a note of this topology quickly, wherein you have a two firewalls, one as a headquarter, another as a branch office. Behind the headquarter, you have one of the client, and behind the branch, you have the another host. Now, we'll make the connectivity between these two public addresses first, then we'll create a tunnel, okay, based on the reachability of public networks. Make sure you are reachable to your internal network. Make sure from the branch office you are reachable to the internal network. Now, here the concept of the tunneling is a little bit different. Here we work like a virtual tunnel, okay? You have to create a virtual tunnel. You have to create the tunnel interface, and those tunnel interfaces should be in the same subnet. Can you see here? I have the 10.30.30.1 as an IP on the headquarters site. I'll create the virtual tunnel interface. That should be assigned with IP address, and that should be assigned with the tunnel destination. So basically here also I'll create the virtual tunnel. Here also I'll create the virtual tunnel, and both the sites I need to keep them in the same subnet. If you have done the GRE tunneling, then it's quite similar. GRE is proprietary. So basically here we'll not be using a GRE. Here it will be a IPsec itself, because without IPsec, tunnel will not be created over here. So you'll be implementing a IPsec protection over here, and after implementing IPsec, then only the communication will happen. Here the GRE protocol is not there. So basically, it works on the same concept, like it's a similar concept. Here, we are going to configure the virtual tunnel interface, and that virtual tunnel interface will communicate after the successful implementation of the IPsec. Okay, so we'll do a side-to-side VPN. I'll communicate within two sites through the tunnel, and I should be able to see the traffic encrypted for these two private networks between the two sites. Am I clear to the topology, everyone?
Yes, Ashil.
Okay. Guys, if I create the topology on the EV, then we can capture the packet. If I do this lab on the like VMware, then I won't be able to capture it. I want to give a try on on the EV. If it is possible, it will be easy to capture and see the packets. What should I do? Okay, let's give a try. Okay, I have EV. Okay, QMO location you want to see. Okay, let the EV get started first. Okay. I can see Palo Alto image is there, 8.0. No, VPN to GUI. Everything will be done. Yeah, everything will be done to GUI. I'll take two Palo Alto firewalls. You can see 4 GB RAM will be required here. So let me suspend these devices. On EV, I'm creating the lab. Okay. So here I need two firewalls. I need two PCs I can take. Okay. So instead of PC, I can take a router for testing purpose as a client, as an internal host, so that it will consume less RAM. Okay. So what I'll do here is I'll take iOS router. It's a HQ client. Okay, I'll just give a name. So this will be HQ site, and I'll take for the branch underscore client. It will act like a branch internal network. Okay. Now I'll connect this with the Palo Alto interface. Here also I'll connect with the Palo Alto interface, and I'll make a direct connection between this Palo Alto. Anyways, after having the ISP or anything, that has to make a connectivity between the two firewalls, right? So instead of adding any separate device for the routing, I made a direct connection. Okay. So these two are the private networks. I'll make a start. I'll start all these devices. You can see all these devices has started. I can take this CLI. Okay, okay. One thing, I need one PC also on both the sides. Okay. I'll take one Windows PC, and this Windows PC, I'll connect it through one switch. And what I'll do, I'll take the management interface of both the firewalls. Okay, both the firewalls management interface, because initially it will be accessible only through the management interface. So I'll connect it with one PC. You can assume this management is reachable, or you can assume both the sites has the different PCs like that. But here in our local lab, I can make the connectivity in this way. Don't assume like this will be connected in the real time. No. In a real time, you can expect here there will be a separate management PC, here will be a separate management PC. Okay. So let me start these devices now. Let these devices get started. I'll open, say it's booting, right? Both the firewalls are booting. Palo Alto 1 and Palo Alto 2 are booting. Let them get booted first. Then we'll assign the IP to the management interface through CLI. Still, these are booting. Let it come up. Today, Palo Alto will be tested on EV also. I basically tested. It is getting a GUI access now. After that, I didn't test anything. Okay, it is ready for login. Palo Alto 2 is also ready for login. Initially, immediately it won't allow you to log in, right? So just wait. Let's see this PC also coming up. I'll log in through admin. Still showing incorrect. This PC is very slow. Okay, I'll connect the IP addresses on these routers. Get started. Palni, see here.
Yes.
This is the place where you should copy.
Okay, okay.
Okay.
Add on. Okay. The three folder same as we have to paste it, no?
Huh. Follow this location and paste it. Okay. There's one thing. Saturday not possible for you, right? Okay. Guys, Sunday we'll have the class. Okay. We'll have the class for around 2.5 hours or 3 hours of class. Okay. Can you guys connect 2 o'clock, afternoon 2 o'clock? Not possible, right? 5 o'clock, 6 o'clock only. Okay. So 6 o'clock, I'll take the class from home. Okay. So you have to log in from home. It will be
Yes.
online class. Okay.
So tomorrow no class, Sushil?
No, tomorrow we don't have class. Even
Okay.
right now, I'm going to end the class. I got some information I have to go. Okay. I'm leaving right now. Okay.
So we will continue IPsec and high availability on the
Yeah.
Sunday.
On Monday, sorry, on Sunday we'll continue and we'll come. Okay. I'm going to
Okay. Yeah. Can you upload this recording as well to the drive?
Yeah, I'll do it. Yeah, 6 p.m. the same time we'll be doing, and that time I'll be totally free. I don't have the other class at 8 o'clock. Like right now, I have 8 o'clock class, right? So right now, that day I won't be having. I'll be free. So that time will not matter for me that day. So I can sit and I can show you. Okay, see you guys.
Yeah.